In an age when Europe was dancing between Enlightenment and Revolution, a boy from a humble family in Brunswick quietly began to rewrite the language of the universe. His name would one day command awe in classrooms, observatories, and scientific journals across the globe. Yet Carl Friedrich Gauss never craved the spotlight. What he craved was truth, elegant, precise, and eternal. He was the kind of mind that could see order in chaos, balance in randomness, and infinite patterns in the silence of numbers. From arithmetic to astronomy, magnetism to geometry, he would go on to reshape every field he touched. He predicted the orbit of distant celestial bodies, proved ancient mathematical mysteries, and gave birth to tools still used in today's sciences, from GPS systems to quantum physics. But who was this man behind the genius? What did he see when he looked at the stars? And why did one of the greatest mathematicians in history keep so much of his brilliance locked away in silence? This is the story of Carl Friedrich Gauss, the prince of mathematics and the quiet architect of the modern world. Carl Friedrich Gauss was born on April 30th, 1777, in the small city of Brunswick, in what is now Germany. His family was poor, his father a bricklayer and gardener, his mother illiterate. But within their modest home, a spark of brilliance was waiting to ignite. From an early age, Gauss showed signs of astonishing intellect. The famous story goes that at just 3 years old, he corrected his father's payroll calculations. By 7, he stunned his schoolteacher with a solution that would become legendary. Tasked with summing the numbers 1 through 100, a laborious punishment for a restless class, Gauss instantly wrote down the answer, 50-50. He had discovered the formula for an arithmetic series, seemingly without being taught. His teacher, astounded, recognized a rare genius. But nurturing that genius in an impoverished home would require help. Enter Duke Charles William Ferdinand of Brunswick, who awarded Gauss a scholarship after recognizing his brilliance. For the first time, Gauss had the chance to formally study, and he devoured every subject in sight: Latin, Greek, mathematics, and beyond. His mother, though uneducated herself, played a quiet yet vital role, carefully remembering the exact day and hour of her son's birth, so that one day he could calculate his horoscope, as was the custom of the time. Gauss would later thank her, not for superstition, but for her love of accuracy, a trait he carried for life. By the time he entered the Collegium Carolinum at just 15, Gauss had already begun exploring ideas that would shape the future of mathematics. He wasn't just a prodigy, he was something rarer, a mind born seemingly already prepared to change the world. As Carl Friedrich Gauss entered his teenage years, his mind soared ahead of his age, and even of his time. At just 17, he made a breakthrough that had eluded mathematicians for over 2 millennia. Using only a compass and straightedge, Gauss discovered how to construct a regular 17-sided polygon, a 17gon. This wasn't just a curious exercise in geometry. It was the first major advancement in classical construction since ancient Greek times. This discovery didn't just earn him prestige, it helped him decide to pursue mathematics over philology. And it marked the beginning of his lifelong habit of quietly recording discoveries in his personal notebook, the Mathematisches Tagebuch, the mathematical diary. In those pages, he scribbled ideas that wouldn't see the light of day for decades, or even until after his death. He believed in perfection over publicity. Few, but ripe, he would say, referring to how only the most refined work deserved to be shared. By the time Gauss entered the University of Göttingen at age 18, he had already rediscovered several theorems independently, including Taylor's expansion and Newton's method. And then, in 1796, in a year he would call his annus mirabilis, his miraculous year, Gauss began laying the groundwork for number theory, a field that would become his true intellectual home. He proved the fundamental theorem of algebra. He began formulating the law of quadratic reciprocity, and he deepened his work on modular arithmetic, calling it the arithmetic of congruences. This elegant system would go on to underpin everything from cryptography to computer science. All this before he turned 21. While the world outside was battling political revolutions, Carl Friedrich Gauss was quietly leading a revolution of his own, one written not in slogans, but in symbols and logic. In 1801, Carl Friedrich Gauss published a work that would forever change mathematics, the Disquisitiones Arithmeticae, 7 words in Latin, but a giant leap for number theory. This wasn't just another math book. It was a masterwork of precision, clarity, and creativity. In it, Gauss didn't just present theorems. He laid out a new standard for mathematical proof. Every argument was airtight, every insight profound. The Disquisitions gave number theory, once seen as a curiosity, the structure of a true scientific discipline. It explored modular arithmetic, congruences, quadratic forms, and the fundamental theorem of arithmetic, all expressed with unmatched rigor. At the heart of the book was Gauss's famous law of quadratic reciprocity, an elegant pattern that reveals when equations like x superscript 2 is identical to p mod q have solutions. Mathematicians had sensed the pattern. Gauss proved it. He even provided not 1, but 6 proofs, each offering a different perspective, as if he saw mathematics like a gem with many shining facets. To this day, Gauss's work forms the foundation of modern number theory, a field now vital to cryptography, computer security, and digital communication. But perhaps just as important as the content was the tone. Gauss treated mathematics as an art form. The disquisitions was not only readable, it was beautiful. In a single book, Carl Friedrich Gauss transformed ancient puzzles into a modern science. He didn't just solve problems, he redefined what it meant to solve them. While Carl Friedrich Gauss was already celebrated among mathematicians, it was the night sky that would bring him into the public spotlight. In 1801, Italian astronomer Giuseppe Piazzi discovered a mysterious object moving between Mars and Jupiter. He named it Ceres, the first known asteroid. But after just 41 nights of observation, Ceres disappeared into the glare of the sun, and astronomers feared it was lost forever. Then came Gauss. Using his own newly developed method of least squares, a statistical technique still used today, he calculated the precise orbit of Ceres based on the limited data available. His prediction was so accurate that, when astronomer Franz Xaver von Zach turned his telescope skyward, Ceres appeared exactly where Gauss had said it would be. He was just 24. This extraordinary success catapulted Gauss to fame. No longer just a theoretical mind, he had proven that pure mathematics could unlock the secrets of the heavens. Shortly afterwards, Gauss was offered a prestigious position as director of the Göttingen Observatory, where he would remain for the rest of his life. Though he never again devoted himself fully to astronomy, he continued to influence the field with his precision tools and mathematical insights. In the orbit of Ceres, the world saw what Gauss already knew. Numbers were not just abstract symbols, they were keys to the cosmos. After his astronomical triumph, Gauss settled into what would become his lifelong academic home, the University of Göttingen. At just 30 years old, he was appointed director of the Göttingen Observatory. From here, he would work in near seclusion for decades, continuing to publish groundbreaking research while rarely venturing far from his post. Despite his growing fame, Gauss had no interest in accolades. He declined offers to teach at more prestigious universities. He rarely traveled. He once said, "I have had my results for a long time, but I do not yet know how I am to arrive at them." It was not modesty, it was perfectionism. During this period, Gauss turned his attention to geodesy, the science of measuring Earth's shape and surface. In the 1820s, he led a massive land survey of the Kingdom of Hanover, walking the countryside with telescopes, theodolites, and custom instruments of his own design. To account for the curvature of the Earth in his calculations, he developed new techniques in non-Euclidean geometry. Though, true to form, he shared little of it publicly. Some of his findings would only be discovered in his private notebooks, long after his death. And when it came to communication, Gauss was quietly revolutionary. Alongside Wilhelm Weber, he developed one of the earliest electromagnetic telegraphs, stringing a wire between Göttingen and the physics lab to send messages using pulses of electric current. Göttingen may have been a small town, but under Gauss's watch, it became a center of scientific brilliance. Every line he wrote, every survey he completed, and every lecture he gave, though rare, carried the weight of genius. His home became not just a place of calculation, but a sanctuary for the world's most refined intellect. Carl Friedrich Gauss was not only a solitary genius, he was also a demanding collaborator. And for those who worked with him, admiration often came tinged with frustration. In 1831, Gauss began one of his most fruitful scientific partnerships with physicist Wilhelm Weber. The two joined forces to explore magnetism and electricity, fields just beginning to reveal their secrets. Together, they conducted experiments, designed the first practical electromagnetic telegraph, and laid the foundation for much of modern electromagnetism. But Gauss's intensity wasn't always easy to match. He expected perfection and rarely offered praise. Students found him intimidating. Some collaborators found him inflexible. The most famous of these tensions arose with Bernhard Riemann, a brilliant young mathematician whose ideas in geometry would one day influence Einstein. Gauss admired Riemann's work, particularly his 1854 habilitation lecture that introduced Riemannian geometry, yet he withheld public endorsement. Some believe he feared aligning too closely with theories that contradicted the accepted Euclidean worldview. And then there was his silent rivalry with fellow mathematician János Bolyai. When Bolyai, it developed a system of non-Euclidean geometry, one where parallel lines could behave in strange, curved ways. Gauss shocked him by claiming he had discovered the same ideas decades earlier but hadn't published them. To praise it, Gauss wrote to a friend, "would be to praise myself." These words, though honest, came off as dismissive, and Bolyai was devastated. To him, Gauss wasn't a peer, he was the Everest he had hoped to climb. Through these collaborations and conflicts, Gauss revealed his complex character, fiercely private, intellectually rigorous, and rarely concerned with academic diplomacy. To Gauss, truth mattered more than credit, and history, in time, would give him both. In his final decades, Carl Friedrich Gauss remained in Göttingen, still writing, still calculating, still driven by the quiet flame of discovery. Though his physical health began to decline, his mental clarity stayed remarkably sharp. Even into his 70s, he continued solving complex problems, reviewing scientific journals, and writing elegant proofs by candlelight. But the later years also brought solitude. Gauss had suffered profound personal losses. His first wife, Johanna, died young, followed by their son. He later remarried, but endured the pain of burying children from both marriages. His relationships were often distant, including with some of his surviving children. While one son followed his father's scientific path, another immigrated to the United States, estranged from Gauss's rigid expectations. Despite these personal shadows, Gauss never ceased working. His contributions to astronomy, physics, statistics, and even actuarial science continued to influence new generations. He reflected often on the nature of mathematics, not just as a tool for science, but as a mirror of the universe's deepest truths. He once wrote, "Mathematics is the queen of the sciences, and arithmetic is the queen of mathematics." On February 23, 1855, Carl Friedrich Gauss passed away peacefully in his sleep at the age of 77. A plaster cast was taken of his face, and a lock of his hair preserved, tokens of respect for a man whose mind had mapped the heavens and reordered the earth. He was buried in Göttingen, under a modest tombstone, marked not by elaborate inscriptions, but by a simple geometric figure, a 17-sided polygon, honoring his youthful triumph. Even in death, Gauss remained what he had always been, precise, elegant, and quietly eternal. Carl Friedrich Gauss didn't crave attention, yet he became one of the most revered minds in history. He was called the Prince of Mathematicians, not for grand declarations or fiery lectures, but for a quiet, relentless pursuit of truth. His name lives on in theorems, curves, and units, the Gaussian distribution that shapes statistics, the Gauss unit of magnetism, Gauss's law in electromagnetism, and Gauss sums in number theory. From GPS satellites to encryption algorithms, echoes of his insights touch our daily lives, even if we never see them. Gauss bridged worlds, pure and applied, theoretical and observational, celestial and terrestrial. He helped recover a lost asteroid, map a kingdom, wire a telegraph, and redefine the very foundations of mathematics. Yet for all his brilliance, he never sought the spotlight. He worked in silence, trusted in rigor, and let the future be his audience. In a world of noise, Gauss remains a symbol of clarity. In an age of speed, he reminds us of patience. And in the endless pursuit of knowledge, his life is a compass pointing true. Carl Friedrich Gauss, the eternal prince of mathematics, didn't just change what we know, he changed how we think. Thank you for watching. If you enjoyed this journey into the mind of Carl Friedrich Gauss, be sure to like, subscribe, and tap the bell for more inspiring stories. Explore more legendary lives on Real Life Legends, where history comes alive.